Okay, practice 5, number 4. This is a long one, has 4 parts. Okay, the tidal wave is a roller coaster at Great America, which accelerates the 300-kilogram car forward at 30 meters per second before releasing it to coast through a 20-meter diameter circular loop and up a ramp, where the car stops and rolls back down to go through the loop backwards. How fast will the car be going when it climbs halfway up the loop to position B? 5,000 joules of energy are dissipated as a car moves through this part of the track from A to B. Okay, so let's just focus on that part first, okay? All right, so we're going to have, let's see, pencil. Okay, right, so A, the car is like over here, okay, and then it's going to go like that, and B is here, C is here, D is here. Okay, A is here. All right, so just ask yourself the questions, okay? First thing, at position A, okay, is the car above the ground? Let's say no, because we'll make this the ground level here. Is it moving? Yes, it says it's going 30 meters per second. Any springs, stretched or compressed? Nope. Any ED? Never at position A. Okay, so whole entire thing is going to be filled up with EK. All right, that's going to be nothing, nothing, nothing. And I'm just going to have to find the EK. All right, so I have 1/2. Whoops. Okay, the mass of the car is 300 kilograms and the velocity is 30 meters per second. Make sure you square it. Okay, so that's going to be what, 150 times 900. I'll do that in my head, but I'm kind of tired. 150 times 900, 135,000 joules. Okay, 135,000 joules. 135,000. Okay, all right, so that's the total amount of energy that I have to work with in position A. All right, so in position B, I'm going to have the same amount of energy. The total is always the same. That's the big idea. All right, so in position B, is it above the ground? Yep. Is it moving? I suppose. It's asking for the velocity. If it wasn't moving, it'd never make it around. Any springs? Nope. Any ED? Yes. It tells us there's 5,000 joules of energy dissipated in this part of the track, okay, because of the friction. All right. All right, so my EG I'm going to solve. No EE, and I'm going to have to find my velocity here, okay? So let's find the EG first. So the mass is 300 kilograms times 10 newtons per kilogram, okay? And then how high is the car at B? It says the diameter of the loop is 20 meters, right? So if B is only halfway up, that means B is going to be up at 10 meters. Okay, so EG is going to be 300 times 100, which is going to be, what, 30,000 joules? Let me just double check. Okay, all right, so my EG is going to be 30,000. Okay, and my ED is 5,000. Okay, and I know I have to add up to 135, so if I do 135 minus 30,000 minus 5,000, I'm going to find out that my EK has to be 100,000 joules. That's what's left over. Okay, 135 minus 30 minus 5. Okay, so 100,000 joules is left for my EK, and that's going to be 1/2. The mass is 300 times V squared. Okay, 1/2 times 300 is 150, so I'm going to have to divide 150 on both sides. Okay, so 100,000 divided by 150 is going to be, bad number, 666.7, okay? And then if I take the square root of that, okay, the V is going to be 25.8 meters per second. So take the square root of both sides, okay? All right, so the EG is about, what, like 1/5 of it? Okay, EK is almost all of the rest. And the ED is like this little tiny sliver at the top. Okay, so the EK is what, like, I don't know, a lot. Okay, ED is a little tiny sliver and EG is like 1/5. Okay, all right. Okay, pause so I can make the next sheet. Okay, all right. Okay, part C. Says on the next page. Okay, how fast will the car be going when it reaches the top of the loop, position C? Another 2,000 joules of energy are dissipated as the car moves through the track from position B to C. Okay, all right, so I already had, okay, let's go through the positions, okay? Okay, all right, so is it above the ground at position C? Yes, because it's at the top of the loop. Okay, is it moving? I'm going to say yes, because it's asking us to find the speed. Any springs? No, and any ED? Yes. Okay, so the ED that we have now is 7,000 joules, right? I had 5,000 already, plus it says there's another 2,000 dissipated in this part. Remember, this number can never go down. It only can go up, okay? So if it's giving it to you piece by piece, you have to keep adding that ED, right? Because like in Skate Park Lab, the thermal bar, the red bar, never gets smaller. You just keep adding into it because that's the energy that's no longer usable. Okay, kind of wasted already. Okay, all right. So the total energy that we had was, oh, I can't remember. What was it? Hold on, I have to recalculate it. I can't go back to the other page. I know you probably know. Oh, was this the 135 one? Times 300 times 900. Yeah, 135. Okay. All right, so the total is still 135. Okay, and then let's see what we've got. Okay, so now the EG is going to be mgh. Okay, the mass, 300 kilograms. The G is always going to be 10. Okay, and now it's at the top of the loop, so that's 20 meters total because it's the full diameter of the loop. Okay, so then my EG now is going to be 3,000 times 20, which is going to be 60,000 joules. Okay, no EE. And I need to find out how much EK I have. So if I have 135,000 total, minus 60,000 is getting taken up by the EG, okay? Minus another 7,000 was dissipated. That leaves me 68,000 joules left to be the EK, all right? Because this plus this have to make the total, all right? Okay, so if I know there's 68,000 joules of EK, all right, and I'm looking for the velocity, now I'm going to go ahead and isolate it. Okay, again, you don't have to do that if you just want to plug it in, that's okay. Okay, times 68,000 divided by the mass. Okay, so I have 2 times 60,000 divided by 300 is 400. And then the square root of that, how convenient, is 20. That's pretty clean. Meters per second. Okay? All right. Please, I'm begging you, you need to punch it in your own calculator. Don't just watch me do it and write the numbers down. Totally worthless. Please, you have to punch it in your own calculator. Okay? Or else come test time, you're not going to know what to do. Okay? So let's see. 68,000 is about half. If it's EK, a little less than half's EG. Maybe like, I don't know, a little less than half is EG, a little more than half is EK, and I have this kind of small amount of ED left over, okay? Let's see, I give it about half for EG, oh no, whoops, sorry, half for EK, and then EG, a little bit is coming out of the EG piece for the ED, all right? Okay, almost done. Position D, at the top, the car crushes a giant spring with a spring constant of 1,000 newtons per meter, a distance of 3 meters as the car comes to a stop. How high off the ground will the car be when it stops at its highest point? Position D, another 5,000 joules of energy are dissipated as the car moves through this track from C to D. Okay, is it above the ground? Yep. Moving? No. Says it comes to a stop. Spring stretched or compressed? Yep. ED? Yep. Okay. All right. So another 5,000 joules of ED, which means now I have a grand total of 12,000 joules of ED. Okay. My total is still going to be 135 because that is never, ever going to change in the problem. Okay. He's above the ground. Yep. Is he moving? Nope. Spring? Yep. Okay. I'm going to fill in my equations. Okay. So I'm looking for how high will it be. So I'm looking for this H. So that's probably going to be the last thing. So let's go ahead and see if we can find the EE. Okay, 1/2, it gives the spring constant as 1,000 newtons per meter, very strong spring. And it says it compresses at a distance of 3 meters. Okay, so 1/2 times 1,000, all right, and then times 3 squared, don't forget to square it. Okay, times 9, so that's going to be 4,500 joules. It's not very much. Okay, so if I have 12,000 of ED, 4,500 of EE, and I have to total up to 135, then I have to subtract. So 135 minus 4,500, okay, minus 12,000 gives me 118, 500 joules left for this. Okay. All right, so 5 times 1,000. Yeah, okay, all right. So that's going to be pretty high, I bet. Okay, so I'm going to go ahead and just fill this in. This is 300, 10 newtons per kilogram, and then the H is what I'm trying to find. Okay, so 300 times 10 is 3,000, so I'm going to divide out by 3,000. Okay, that's going to be a Newton. Okay, so 118, 500 divided by 3,000 is going to be 39.5. So it gets like almost twice as high as it was in this roller coaster, twice as high as the loop. That seems okay. All right. Okay, so it's mostly EG, right? Like, I don't know, way more than half, maybe like 3/4. Okay, no EK, a little sliver of EE, that's not very much, and then more ED, about twice as much. Okay, so sliver of EE, tiny bit more ED, and then the rest EG. Okay, all right, that is number 4.